We're continuing on looking at the Chapter 3 group review. Be careful with this video. This video goes over problems 4, 6, and 8. And that's because I'm going to group the trigonometry problems together in one video, and I'm going to do the segmentation problems separate in its own video. So this one deals with problems 4, 6, and 8, which deal with first, problem 4 is how do you divide a polynomial using the area model? And so remember, division is just the opposite of multiplication. So I'm going to take the time and I'm going to set up my multiplication structure using the area model. So I'm going to create my boxes. So I have this right here, and I'm going to go across. Now, how far do I go across? That's the question some people have, is how many do I create? And so the way to go about it is I know inside, when I deal with the area model, inside this box is that x to the fourth minus x cubed minus 7x squared, dot, dot, dot. That's going to be the combining of everything in the box. So I need to figure out how many columns am I going to have. And what I do is I look at it, well, the first column, this top row, and I'll go ahead and create the rows for them as well, the full outside of the box. This top one, top left part of it, has to be your x to the fourth power, because nothing is going to be able to combine with that. So this x to the fourth has to go here. And that's helpful because I know the next column is going to be, and I'll just mark it, this one has to be an x cubed. This one has to be an x squared. This one has to be an x. And this last one has to be a constant. So I realize if I go through and do it that way, I'm going to have, in this case, 5 columns. Now there's a way to do 4 if you put the remainder on the outside. I'm not one to judge. So when we go through, that is the first setup. And then I need to realize this x plus 3 is going to be what we're multiplying. So our job is to figure out the top of the box, the top of the rectangle. What is going to be multiplied there to give me that x to the fourth minus x cubed, dot, dot, dot. Well, I already have the top left part of the box. I already know that x times this top gives me x to the fourth. So I can right away put in there, right on top here, x cubed. That x cubed times x is x to the fourth, perfect. Now it's all going to be like a domino effect. I can fill in the rest of that column because x cubed times 3 is going to be a positive 3x cubed. And you may go, well, I'm done. I can't go any further to the right. And you're wrong. Because I know what the inside should combine to give me. I know that inside should combine to give me a negative 1x cubed. But the problem is I have a 3x cubed. So I need that diagonal to combine to give me a negative 1. So if I have a positive 3 and I need a negative 1, then that means I have to create a negative 4x cubed here. I mean, 3x cubed minus 4x cubed, negative 1x cubed. Golden, we got that one done. Well, now we're at the same place we were on the previous column. The previous column had that x to the fourth. Well, I can figure out the top now. I know x times this is going to give me negative 4x cubed. So that has to be a negative 4x squared. And I can finish the column, just like I did before. So negative 4x squared and 3 gives me a negative 12x cubed. Perfect. But there's a problem. I don't want negative 12x cubed on the inside. The inside combines to give me a negative 7. I apologize. It should be negative 12x squared. So, I'm not going to re-edit this. My apologies, that happens. So that's a negative 12x squared. I wanted negative 7x squared. And so I need this and this to combine to give me a negative 7x squared. I have negative 12. I want negative 7. So I'm going to add 5x squared here. Negative 12x squared plus 5x squared, negative 7x squared, boom, golden, we're done. Now we're in the same place we were back when we were in the second column, back when we were in the first column. I know what creates that top row, so I have to now figure out what multiplies to give me that. So I have x times this position gives me a 5x squared. And so that's going to be a 5x. And now that I have that top, and I'll keep the color coding that I have on, now that I have the 5x, I can finish the rest of that column. 5x times 3 is a 15x. But the problem is I don't want 15x on the inside. On the inside combines to give me a 26x. I only have 15x. So something needs to be put here to give me that 26x on the inside, and that's going to be an 11x. And I'm repeating myself, right? I'm in the same place I was in the previous column, and the previous column, and the previous column. I know what the top row is. I need to figure out what multiplies above it to give me it. So x times up here gives me 11x. Well, x times 11 gives me 11x. And then just finish the column. And that'd be a positive 33. Well, we have our 26x. That's nice, but I need 38 on the inside. I mean, look at that. 38. All I have is 33. So I probably need to put a positive 5 here. And that would give me the 38. So what does that 5 represent? Well, look at your polynomial. I have x cubed minus 4x squared plus 5x plus 11. Well, I'm already at my constant. I'm at my last position. So remember that at the end represents your remainder, big R. And so when we go through, I have to figure out how do I write my answer. I'm going to write my answer by saying x cubed minus 4x squared plus 5x plus 11 plus a 5 over an x plus 3. That's your answer. Put your remainder over what you divided by. So there's polynomial division. I know I took some time because I know some of you are struggling with it, and I want to make sure you can understand how we created the inside of the area model for it. Now the next one is a system of equations. So in this case, I'm going to think about looking at substitution. X squared plus y squared equals 10. Y minus x equals 2. So hold on a second. I'm going to think about this. I'm going to solve. I'm going to take this equation and I'm going to solve and say y equals x plus 2. And I'm going to use substitution. I'm going to take that and I'm going to plug this in for that y in the original equation. But I'm going to stop and I'm going to pause for a minute and think about this. X squared plus y squared equals 10. That is a circle. So that right there, x squared plus y squared equals 10, that is a circle. Y equals x plus 2, that's a line. How many possible answers could I have here with a circle and a line? Well, I could have 2 answers intersecting anywhere through the circle, like a chord. I could have no answers by just being above the circle. Or I can go and get one answer by just hitting this one side. We call that being tangent to the graph. So in this case, I could have either 0, 1, or 2. And that's what's going through my mind. I'm thinking before I start what my answers are going to look like. Personally, I'm leaning towards 2. There's more of a chance of it occurring, so I'm thinking 2 answers, which again, how do I create 2 answers? Well, I can either factor, since it's a quadratic, or remember, if I'm square rooting, it's a plus or minus. So those are my 2 things in my mind that's coming across. So let's just go ahead and get started on this. We're doing substitution, so I have x squared plus y squared, but instead of y, I'm substituting in that x plus 2. And that equals 10. Warning number 1. Don't be that student who goes, I'm going to distribute the exponent across a plus sign. Those operations don't go together. Don't do that. When you're squaring something, it means you need to multiply by itself. So if you need to, you can set up an x plus 2, and you can set up an x plus 2, and I'll just do it up here, and you can multiply them out and get your answer. I'm going to just go ahead and write it down. And because at some point you need to improve those skills, because those skills are your algebra skills, and you're in pre-calculus, you need to make those skills go faster. So I'm going to square x plus 2, and I would get an x squared plus 4x plus 4. and that should equal 10. Again, it's a quadratic. So when you're solving a quadratic, you have to set it equal to 0. So I'm going to combine my like terms and set it equal to 0 at the same point. Now right here, you could go into using your area model to factor. 2x squared plus 4x minus 6, and I can use my area model. I'm not going to, because when I hear 2x squared, 4x, minus 6, I can tell they're all even. So I'm going to divide. I'm going to make these smaller. I'm going to divide every term on the left side by 2, and I'm going to divide every term on the right side by 2. And it's lucky I can do that because they're all even. But even, the right side is 0. And 0 divided by 2 is 0. So I'm going to have x squared plus 2x minus 3 equals 0, because I divided everything by 2. That's a much easier quadratic to factor there. 1 multiplies to negative 3 and adds to 2. That'd be a positive 3 and negative 1. So there we go. And look at that. I have 2 x's. I'm going to have 2 solutions. I know one of them is going to be when x equals 3. And I know the other one is going to be when x equals negative 3. And the other one's going to be when x equals 1. These are coordinates. So I know my answer is going to be negative 3 something and 1 something. And it does matter which x gets paired with which y because they are coordinates. So I'm just going to plug it in. And again, come on. We're going to be a little bit faster with our work. Because you know what? You're in pre-calculus. You've earned it at this point. I mean, if you're plugging in negative 3, it's going to be negative 1. If you're plugging in 1, it's going to be 3. At this point, I mean, there's no real necessity to do this. Do some of it up here. Save yourself some of the time. And that is my answer for it. So we are set. We know what our answer is, and we can move on to the next problem. So apply U substitution to factor and solve 2 parts. And blue we'll do for the factoring, and then we'll do a different color for the solving. And in this case, I take a look. That looks awful. 3 times quantity 2x plus 5 squared plus 8 times 2x plus 5 minus 3 equals 0. I don't want to factor that. What I'm going to do is I'm going to define. And a lot of students, here's what you did in your checking quiz. And I understand, is you went right away because of the directions and said, I'm going to write down 3u squared plus 8u minus 3 equals 0. And that is the correct structure for U substitution. However, and I use this in my AP Stats classes, if you don't define it, you don't get to use it. You used the variable u, which means you should define the variable u. And you're letting u equal the binomial 2x plus 5. Write that down off to the side, save it, especially when we're saying we're going to factor and we're going to solve. We're going to need that later on. So this is going to involve my area model for factoring. So I'm going to have my box, and I will just draw, here we go, boom, boom, boom. And I'm going to put the 3u squared here. I'm going to put the negative 3 here. Now remember, this diagonal is going to add to give you 8u, but it's going to multiply to give you negative 9u squared. So it multiplies to give you negative 9u squared, and it adds to give you 8u. I'm thinking that is going to be a positive 9u, and it can be a negative 1u. Negative 9u squared, when I multiply, yep, and I add to get 8u, I'm good. I can move on from there. So I'm going to create the outsides. The top row has a GCF of a u. And I just think of it like what I did when I was dividing. Oh, this would be a 3u. This would be a 3. This would be a negative 1, and check it. Yep, it does work. So my factors, again, going back to blue, are 3u minus 1 and u plus 3 equals 0, because it's an equation. So right here it says apply U substitution to factor. I did. But I need to finish it, because the original problem has x's. Mine has u's. I need to go back and say, you know what? I'm going to take this 2x plus 5 and I'm going to put it back in to those u's. So when I go through, I have a 3 times 2x plus 5 minus 1. 3u minus 1. Again, let's try and shorten some of our work. I'm going to distribute the 3, and that's going to be a 6x, and it's going to give me a 15, but then I'm going to subtract 1. And there we are. When I go over to the other one, I'm going to have a u, which is just 2x plus 5 plus 3. And that is 2x plus 8. And that equals 0. Now, I'm going to do this. At this point, it usually doesn't happen here. I just made up a problem. I'm cringing inside because the first factor, 6x plus 14, it has a GCF in common, and that bothers me. So I'm going to factor out a 2 from the first one, and that would give me a 3x plus 7. And by the way, the second factor also has a 2 in common. It's 2x plus 8. So I'm going to factor out a 2 from there as well. I'll put it over here, and I'm going to get an x plus 4. And so I have a 4 times 3x plus 7 and x plus 4. Now, that's because it bothered me. Sorry, I have to do this properly. And now that's the factored form. Again, with you, I would accept that or that. That's completely fine. And I want to show you what the difference is. I'm going to solve mine. If I solve, there is no variable here to solve for, so that's done. Because technically I could divide that 4 out on both sides. It could just disappear. I'm going to take 3x plus 7, set it equal to 0. I would subtract 7 and divide by 3. Great. I'm going to take x plus 4 equal to 0, and I'm going to just subtract 4. Now, how do my solving steps relate to yours? If you had this 6x plus 14 times 2x plus 8 as your factors, you ended up simplifying negative 14 over 6 and getting negative 7/3. So I did that simplifying in this step. That's the difference between them. Is by factoring out that GCF beforehand, I dealt with smaller numbers rather than dealing with the fractions and then simplifying. So that's the differences between them. So there are your 3 problems over this. The next video should go over the trigonometry problems.